Now you can hear me. Hi, my name is James. I'm from the Aquarium Education Department here at the Aquarium Pacific in Long Beach, California. We're going to be talking today about one of my favorite kinds of animals all over the planet. It's the octopus. The octopus is an amazing animal with so many interesting adaptations and the abilities to do so many things in their environment. We'll talk about how they survive, some of their important abilities, but also show you some really interesting clips about some of the animals that live right here at the aquarium. So let's look at an example of an octopus. Here is one of them. Now, while we're doing our program, don't forget, you, the viewer, can hang out and watch and interact with us too. So not only can you learn while we're going, but you can ask us questions that we can answer on the air. So if you text us down to this number right here, 562-286-1838, my friends in the office will be able to answer some of the questions, but they'll also give me some of your questions to answer on the program. Now, if you're watching when we're not airing live, don't worry, you can still participate. You can email us at live@lbaop.org. This email will be answering questions in too, so if you're watching live or after the fact, don't worry, you can still have some fun asking us questions about our animals. So today we're going to be making observations. We're going to be using our main senses, our eyes and our brains and our ears, because you're listening to me, to really take a look at these animals. The octopus is a special animal. It belongs to a group called the cephalopods. Cephalopods include the octopus, squid, cuttlefish, and the nautilus. Now we have a few pictures of each, but don't worry, we'll show them to you in a little while. If you don't know what any of them are, we'll make sure that you know. Now the octopus is a very interesting animal. It is very different from almost anything else on this planet. If you were to imagine or invent an alien animal that had somehow shown up on our planet, this might be something that you had thought of. They have very different bodies than a lot of other things in the ocean. So let's talk about some of their important features. What do you know about the octopus? Remember, you can not only text us questions, but text us some of your observations or some of the information that you know. My friend Emily will be able to share some of that with us. Amanda's in the control room. She's helping control the computer with the pictures. What did you find? What did you notice about the octopus? We have a really good observation. These are suction cups. The suction cups on their tentacles are very distinct. Not everything that is a cephalopod has the same kind of suction cup. What else did you notice on the animal's body? What about this part right here? What is that? That's not just any dot. That's their eyes. They have eyes. They can see. They can't see exactly the same way that we do, but they do have the ability to see. Anything else that you noticed about them? Not a ton. Let's go back to the video we were just watching of the octopus hiding in the rocks. Let's see if we can make some other observations of what's going on. What is this octopus doing? We can find the eyes. We saw the eye. There's you can kind of see the suction cups in there. What else do you notice this animal doing? Does it look like it's breathing? That almost looks like a mouth to breathe in and out. It's a little bit different body part. That is called a siphon. So they don't have an airway like we have. We have our mouth, our nose, our throat, and into our lungs. We have an entire system designed to hold in air. But they don't breathe air, do they? They breathe water. Here's a close-up of the siphon. So now I see two parts moving in here. One and then two. Can you hypothesize or guess what's going on here? Maybe one side is the in, one side is the out. So they are pulling water in here, and then they're squirting the water out here. But where is that water going? Remember, they do breathe the water, so it's going inside their bodies. But they don't have a process like we do, where it goes just in one tube and back out the same tube. Their bodies are a little different. Now, if we have our cuttlefish picture, it's a little bit easier to see on a cuttlefish the orientation or layout of the animals that are cephalopods. So cephalopods have an elongated body. So we see Here's the tentacles, here's their eye, and here's this big section back here. Now, on an octopus, this kind of looks like that should be their head, right? Well, where's the head of an octopus? It can't just be tentacles and head, because then there's no other organs. There's no other guts or body parts. So here's a little bit smaller one. Where are all the guts? Where's all the intestines and other things like that? Well, they've got to be back here. So in the middle is the head of a cephalopod. The appendages, or you might think like arms and legs for us, there's the tentacles and arms for different kinds of cephalopods. And then back here, see, here we go. Here's a nice picture of an octopus where it looks like they just have a big bulbous head in the back. But this is not the head. The head is only this section right in the middle, right between where their eyes are at. So their tentacles are on one side, that side. Their head is in the middle, and then this is like what we would consider our abdomen. This is what we call the mantle in a cephalopod. Actually, in a lot of animals, we call mollusks, the soft-bodied animals. So this is their abdomen. And their gills, their intestines, their stomach, all the other body parts they have are back there. So while it looks like a head, it's actually like their tummy. So if you wanted to design your body to look like a cephalopod, what would you do? Our body's in a little bit different orientation. Our appendages are all over the part that holds all our guts in, and their head's on the end. So, what would you have to do? You'd have to pull your arms and legs off, glue them to your face, and that's a cephalopod. You've now become a cephalopod. So their body is a very different design than ours, and not all of them have the same kinds of insides either. So this octopus, this is a two-spot octopus. They live here locally in Southern California, named because of these very fun little spots right here, one on either side. Does that look like anything to you that you recognize? It looks like another eye. This is a false eye spot. Some animals have those. Not all animals, but some do. And this is to help confuse a predator so they don't try to poke them in the real eyes. All right, we have a bunch of questions coming in, so let's try and answer some of these while we're hanging out today. So Matthew is asking, how long are their tentacles, and do they grow back if they're taken off? That is a good question because, one, size is important. We want to be able to understand how big things are, especially compared to us. But two, some animals have the ability to regrow entire parts of their body. Well, the size of the animal really depends on the type of animal they are. So a two-spot octopus like this is probably not any bigger than like a football. Think of like a college-sized football. That's about the size of a two-spot. So their tentacles are not super long. But the tentacles of the biggest octopus, the giant Pacific octopus, has tentacles that can spread almost 20 feet across. And we have a video of one of ours. This is the giant Pacific octopus. Now, this is a large animal. Their body is huge. I think at the time that this video was made for this octopus, she was probably about 45 pounds, maybe. But the largest I think I've ever heard of a giant Pacific octopus being is 100 pounds or more. That's a big animal. And their tentacles can spread very far. So it just really depends, Matthew, on which animal it is. Now, for their cousins, the giant squid, their whole body is about 60 feet long with tentacles that are probably 40 of those feet. So giant squid are an amazingly large animal for not having any bones. So that's another interesting adaptation we'll talk about in a second. So the giant squid is a very huge animal, and at least half of their body length is tentacle. So depends on who you're talking about, which cephalopod, and how long their tentacles are. Good question. Alexa's asking, how many suction cups per arm, and why do they have them, is the follow-up from Braden and Reagan. Well, let's go back to a picture of some suction cups on tentacles. So here we can see them. Now, I'm not going to try and count them live for you. You might want to try and come back, as startled our camera person. You might want to try and come back and count them yourself. But the estimates that I've heard from a giant Pacific octopus, not them specifically, they didn't say anything to me, but about them, is that they have about 250 suction cups per tentacle. Now, here's the cool thing about that. Just like we can control our fingers, we can even count with our fingers. We can move them independently. An octopus can move each suction cup independently of another one. Could you imagine having 250 fingers on each hand and you can move each of them on your own? If you have a piano teacher, I'm sure you would just delight them with the amount of music you could play. But that's how interesting their bodies are. They have an amazing amount of muscle control over each of their suction cups and tentacles. Now, why would they have this part of their body? What do our hands do for us? What is the adaptation? What is the reason we have these? I can grab stuff. So if I wanted to pick things up, say like this piece of coral, hands help us do that. Not every animal in the world has hands. Not every animal even has hands like ours. Some animals don't have what we call an opposable thumb. Our thumbs can do fun things, not just thumbs up, right? They can help us hold and grip. So some animals don't have that. They have to try and grab things without moving your thumb. That could be an interesting game you play with your friends at home, is try to pick things up without using your thumbs. How would you try to hold things like a sea otter? Okay? They don't really have opposable thumbs like we do. So these parts of our bodies help us grip and hold on to stuff. Suction cups do the same thing. They also help them feed. Now, in a little bit, I'll show you a video of an octopus feeding. So the tentacles and the suction cups are for moving and grabbing stuff. That's really their big purpose, is doing all of that. Now, the other cool thing, I don't know if you want this adaptation. Now, I would love to have amazing adaptations like the octopus does, but the suction cups can also taste their food. So imagine every one of your fingers could taste everything you touch. I don't think that would be very fun. But that's how the octopus body is adapted and set up to live in their environment. Okay, Katie, who is age 4, welcome and thanks for viewing, Katie. Alyssa and Haley, we have a big group of people asking this question. How do octopus change colors? Ooh, do I have a treat for you? I have a couple of videos showing how they change color. I'm going to step out of the way, and let's try and show you what octopus do when they change color. So here we see the octopus is hiding. Oh my gosh. Did you see all of that? That is amazing. Not only can they change color. Oh, here it comes back. Never mind. But they can, it's kind of in between. It's kind of like we paused it right in the middle where we needed to. And they can change the texture of their skin too. So how do they do that is an important question. The octopus, along with a lot of their other cousins, have these special cells in their body called chromatophores. Chromatophores are kind of like microscopic windows that open and close to show you color in the window. That's how special their skin is. Their skin is so well adapted and so specific within nerve control from their brains, they can change the size of these cells opening and closing to show pigment. Now, they can do that all over their skin, not just in a couple of spots. Like, we can kind of change color. Like, you get really embarrassed, your face gets all flushed, and you turn a little red. That's not, we don't purposely do that to ourselves. But imagine if you could force your skin to change colors suddenly. That's what they can do. So, great question about octopus changing colors. An amazing adaptation. And remember, the big science word for that is chromatophores are the big cells that do that. Now we can see an octopus do the other thing. So we saw an octopus swimming around and wanting to get into the coral to hide. Well, what if it's already in there? Let's try and use our powers of observation. There it is. So once the octopus realized it was spotted, it tried to change colors and swim away. So here we go. Here's another one. So it's crawling into the coral. And there we go. So that was the first one we watched. So that is a very quick change. They can almost instantly color change and skin texture change on their bodies. So here's that other one again. Very quick. Now, we didn't speed this up. We didn't modify the video in any other way than maybe brighten it up a little bit because it's kind of dark in the ocean so that you could see everything that's going on. We can watch the cuttlefish feed and color change too. So this is about octopus, but let's check out the cuttlefish because they're really fun too. The cuttlefish is their cousin. We talked about them a little bit already. Yoink. And there they go. their bodies have a little bit different tentacles. You can see the suction cups on that cuttlefish's tentacles. Now, they have tentacles and arms, which is a little different than an octopus. An octopus only has tentacles. The octopus has 8 evenly length tentacles, or almost even, but the cuttlefish and their cousin, the squid, have 2 extra long ones for, remember you saw that? Reaching out, grabbing their food and pulling it in. So they had 2 just for doing that, and then the other ones help hold on to their food, and they can eat with them. So that kind of leads into Ender's question about where's the mouth. So here's a picture of the tentacles and arms. So on a squid and octopus, it's very dark in the deep ocean. That's why it looks like this. I'm kidding. We'll put it back up. So here's the octopus. Tentacles on an octopus are all the same, okay? But a squid and a cuttlefish, 2 long tentacles, and they have other arms that are shorter that have suction cups all the way down. So there's a little bit of difference on their bodies, but that's okay. They all have similar body parts for similar functions, and they have different adaptations for that. So Ender was asking, where's the mouth? Well, in between all the tentacles in there is where their mouth would be. And their mouth is a very interesting design. Have you ever heard what the shape of an octopus or squid mouth is? You might have heard of it. You might have even shouted it out to the TV or texted it into our friends here in the studio. Their mouth is the shape of a bird's beak. It's exactly the same design as what you might think of a parrot beak. So 2 overlapping halves that are shaped and curved so they can grab and crush and bite open their food. So their mouth is in between all of those tentacles. All right, now I think we might have the video of the octopus eating with one of our aquarists. I'll step out of the way because this is going to be a full screen one. So we're asking about what do the tentacles do? What do the suction cups do? Where is the mouth? This is our little red octopus. He's very cute. Don't worry. He's not hiding from us. What happens is we provide puzzles and games and things for our octopus to do. They're very smart. We have to keep them busy and test them with what we call enrichment. It's kind of like playing a brain game. So JJ is one of our aquarists, and what she's doing is putting the food in a different space than where the octopus is at. The octopus has to crawl its way out, squirt out any water that's still stuck into its mantle, and then it can taste and smell the food in the water, but it has to get it out of the container. How is it going to get in there? Oh, it figured it out. It can pull open the lid, and our little red octopus is so enamored with having solved this puzzle. Not only does it eat the food, it goes and hides inside the box to eat the food. That's a pretty interesting ability for them. Now, Reagan is asking, is it true that they can squeeze themselves into small spaces? Well, that box seems like it's not much bigger than the octopus, so it's pretty close. We might have a picture of an octopus squeezing itself into a really small space, but they do have this really interesting ability. Octopus do not have bones. The only hard part of an octopus is the mouth. So whatever their mouth can fit into, the body can fit into that too. That is a very special ability, especially when you live in the rocky reef or in a coral reef. You're living on the sea floor a lot of the time. There's a few types of octopus that live in the open ocean. They still have just the one hard part, the mouth, but they have another ability to swim around in the open ocean too. All right. Let's go back to looking at the siphon and the sneaking into the rocks. Now this octopus not only sneaks into the rocks, but it moves the siphon to the other side and it inks. How many of you are telling us that the octopus is inking? That is a really good ability to try and hide. Now, this one didn't ink very much, and that's okay. But they can use their ink as a cloud to confuse their predators and hide. This one is trying to squeeze into those little rocks. Because they have no bones, as long as their mouth can fit through the rocky spaces, their whole body will fit into there. Well, there's a good question about, well, where's the mouth? So then a follow-up must be, what do they eat? Well, let's think about animals that live in a space like this. A rocky seafloor. Who might live down here that an octopus can eat? While we think about that, Brandon's also curious about how they digest their food. So what do they eat, and then how do they digest it? Well, while you're thinking about animals, let's talk about how we digest food. So the first step that we have is we have to chew our food. We mash it up, and we can swallow it. So that already turns it into a soft material. In our stomach, it starts getting even more mushed up. The muscles of your stomach crush and smush and turn and mush up your food along with the enzymes and the stomach acid to turn your food into a liquid. And from there, it goes into our intestines, and we can absorb the nutrients out of our food. Very similar process for an octopus. Their mouth breaks open the food, they take bites out of it, and then in their stomach, the enzymes and the digestive acids will help break it down before it moves into their intestines. Now, if an animal is eating, where does the food go after they've digested it? Well, they all have to go to the bathroom too. So if an animal eats, it has to go to the bathroom, and they do poop, but it has to come back out in the same area. So on the round where the siphon is at, everything that comes out of their mantle cavity, the part where their guts are at, comes back out towards the siphon. So it's kind of an all-purpose organ. All right, let's go back to one of the pictures of one of our other cephalopods so we can try and show you a little bit more about their bodies. This doesn't quite look like what we've been looking at, is it? Is there something the same? What is the same about this cephalopod? It is a cephalopod. I noticed that eyes. Doesn't quite look like an eye like we think of, but that's the eye. What about these? They have their arms and tentacles in there too. So this cephalopod is a little different. It has a shell. It is the only cephalopod that has an external shell that's still alive that we know of. Now this is the hood, so they can hide all the way into their shell and close their body down, and the hood will help protect the rest of their body parts. So where's the mouth? In between all of the tentacles. And then inside is where all of the guts are at, all of the organs, the stomach, intestines, gills, all of those body parts are in the middle. Now, there's a really cute squid that lives at the bottom of the ocean called a bobtail squid. We didn't always know about the bobtail squid. This one was discovered on a deep sea research dive from the NOAA vessel, the Okeanos Explorer. So we might think we know a lot about this group of animals, but we don't know as much as we think we do. And we're always discovering something new and special. That's the beautiful part about science. Science is about discovery and learning. We're always finding new things. We're always even learning things about ourselves. We might think we know everything about the human body, but just a few years ago, they had to redescribe a part of the human knee because somebody found new research that it was actually a little bit different than what we thought it was supposed to be. So we're always learning stuff in science. Now, Adam is asking, why does octopus skin change from spiky to smooth? Good question. Why would you want to change the texture of your skin? Let's go back to watching this octopus. What is this octopus sitting on when it changes the texture of its skin? Remember, camouflage can be color changing, but it can also be texture. Yeah. So let's imagine we wanted to go hide out in nature. Ultimate game of hide and seek. You could use nature around you to help you hide, not just kind of hide in a space that somebody can't see you from. Well, I might grab some sticks or branches and kind of stick them to myself so I look exactly like the stuff I'm hiding around. Well, they don't necessarily need to grab stuff. An octopus can change the texture of its skin to look like the texture of the stuff it is sitting on. Now, their skin is extremely soft. I've only touched an octopus a couple of times in my life, but they are extremely soft. So they're not going to become suddenly very spiky and dangerous, like you wouldn't want to touch them because they're like pointy like a needle. But if you look so similar to what you're sitting on that another animal can't tell because you're the right texture and color, they will probably miss you altogether and not find you. Good question from Adam. Now, Alexa is asking, is it true that the mother dies after giving birth? Well, here's a baby octopus. Very small. So that octopus is probably not any bigger than your thumb or pinky nail. Well, what happens when an octopus lays eggs? So they don't give live birth like we do. Mammals give live birth. Other animals lay eggs, or they do some other process to have babies. Well, an octopus is very similar to other animals in that they lay eggs. For a while after they lay the eggs, the mom has to protect them. It takes a little while for the eggs to hatch. So mom finds a nice cave somewhere, sits in the cave, lays the eggs, but then has to make sure that the eggs hatch. So the mom will stay there and kind of brush new water into the little cave to make sure they get enough oxygen, because oxygen can get into the egg. It has to be able to move through the surface of the egg so that this little baby octopus can breathe. They have gills, so they have to breathe the water. But then mom has to also protect the eggs from something else, from finding them and eating them. There's a lot of predators that will eat eggs. There's a lot of nutrition, and it's an easy resource for a lot of animals, only if they're not guarded by the adult. So if the adult is guarding the eggs, making sure fresh water, seawater, something new to get more oxygen on the eggs is happening, they'll protect the eggs until they hatch. And then once the eggs hatch, the mom will often die. Now, the unfortunate part about cephalopods, all cephalopods, is they don't have a very long lifespan. I wish they had really long lifespans so that we could hang out with them and learn from one individual for a very long time. But most octopus and other cephalopods only live for 1 to 2 years. Some might live 4 or 5 years, but they don't tend to live very long, which is kind of sad, but that's part of the cycle of nature. That's what is going on. So they will have a lot of babies all at once. And then because they're staying in the cave, they guard them. They're not going out and eating, so they're not finding food. So they tend to starve and wait until the eggs hatch, and then their role has been completed, and they will unfortunately die. Sometimes they die before the eggs hatch. Sometimes they survive a little bit after the eggs hatch. But in general, it's about the same time that the eggs start hatching that the octopus parent will die. Okay. Emma Adams is asking, what is ink made out of? I'm not entirely sure, but it is something that mixes with water. So what doesn't mix with water? What in your kitchen could you have tested before that does not mix with water? I'm thinking of like cooking oil. So oil and water, they don't mix. The chemistry of the two, they don't like to mix together. So things that are similar will mix. Things that are not similar do not mix. So if you try to mix two kinds of oil together, they will mix together. If you try to mix maybe water and milk together, they're both water-based, or similar to water, they will mix together. So ink does kind of have this watery mixture to it. It's what we call concentrated. It's very thick. And then once it's squirted out into the water, it will turn into this big cloud. So it kind of dissolves into the water. Here's that squid inking again. Let's take a quick look. Now, in some cases, a cephalopod can use a really mucousy or goopy ink. What would be the advantage of throwing goop at something? Don't try this at home unless you have permission. But what would be the advantage if I had a giant, like, mucus water balloon that I chucked at something? It's gross. Don't do that. But what would be the advantage? If you are a predator, you're trying to eat that thing, and suddenly there's this large glob of mucus that gets at you, sticks to you, maybe gets in your gills, it prevents you from doing what you need to do to hunt that animal. So ink in some cases is just a cloud so they can disappear. In other cases, it will help gum up everything so that the predator will feel it's too much work. They don't want to continue hunting that animal. Okay. Now, Cora's asking, how big is a giant Pacific octopus's mouth on average? Well, let's see. Since I don't have an actual mouth with me, let's see if one of my other artifacts might be similar enough in size. Okay. I have here a helmet snail. Now, the approximate size of this, so maybe a closed hand on one of our younger guests, maybe not my hand, but a closed hand on one of our younger guests, that's about the size of the mouth of the biggest of the giant Pacific octopus. On other squid and octopus, their mouth might be very thin or small. So each species has a little bit different sized mouth too. So just like each species has a different length of tentacle, each species has a different size of mouth. Now, a good question is from, it doesn't say have a name, but it does ask, do squid eat each other? A lot of animals in the ocean are what we call cannibals, meaning they eat the same species that they are. Not every animal does this, but a lot of them do. They don't tend to eat the same kind of animal. They do often hang out in the same area, or they are feeding on the same, they're scavengers, they'll feed on the same carcass or dead animal of something, but they don't tend to eat each other of the same type. Now, they might hunt another cephalopod of a different size or species, so it is possible they might eat a different kind of squid or octopus, but they really don't eat the same kind of squid or octopus. I want to thank you all so much for bringing in some questions. I think we have a couple last-minute questions we'll get to answer for you on our program today about octopus animals. But don't forget, throughout the live programming, you can text us. If you're watching after it's aired live, you can still ask us questions and participate with us in our education department. Email us at live@lbaop.org. Now, we'll have one of our staff helping answer questions on the email. And I think Emily was fiercely typing away. You were all typing in so many questions that she's been very busy. But once again, thank you all for joining us for Aquarium Online Academy today. And keep tuning in. We'll be talking about diving next at 2 o'clock. But we'll also have more programming tomorrow at 9 a.m. Check our website for upcoming programs. You can also watch us on our YouTube page, too. We also have a lot of other online resources that you can check out. We have teacher resources, student resources. We have worksheets. We have activities on our website. But also check out our social media. There's a lot that we're trying to present to our friends that are at home during this crisis right now so that we can still make sure that you have some fun things to learn and that we can help interact with you in just a little bit. Thank you, everyone, and enjoy the rest of your Thursday afternoon.